This is in October, November 2022, variant 41 question, number 9. Part A, what is meant by the luminosity of a star, which carries 1 mark? The luminosity of a star is the total power of radiation emitted by a star. Then in part B, a star in the constellation has a distance of 8.14 times 10 power 16 meter from Earth and has a luminosity of 9.86 times 10 power 27 watts. The surface temperature of the star is 9830 Kelvin. Part 1, you have to calculate the radiant flux density of the radiation from a star observed from the Earth. Give a unit for your answer. So the formula to use is F equals to L over 4 pi d squared. F is the radiant flux density. D is the distance which is given to you, and L is the luminosity. So therefore, your F equals to 9.86 times 10 to the power of 27 divided by 4 pi times 8.14 times 10 power 16, then you square it. So the answer will be 1.18 times 10 power minus 7. Why unit is watt per meter square? Because the unit for luminosity is watt. And then the unit for D is meter. So D square will be meter square. Therefore, units will be watts per meter square. Then in part 2, determine the radius of the star. The formula to use is L equals to 4 pi constant of proportionality R squared D to the power 4. Your L is given to you, and then the constant of proportionality is what? 5.67 times 10 minus 8. And then the radius, the temperature of the star is 9830 Kelvin. So from there you can find the radius. The radius is 1.22 times 10 power 9 meter. Then for part C, which carries 3 marks, explain how the surface temperature of a distant star may be determined from the wavelength spectrum of the light from the star. This question carries 3 marks. So the first mark will come from the wavelength of peak intensity, which is a peak wavelength determined from the spectrum of the star. Then your second mark is the wavelength of peak intensity from object of known temperature determined. Then after use your Weir displacement law, or wavelength of peak intensity is inversely proportional to T to determine your F. To determine your temperature in Kelvin, sorry. This is a summary of the facts that you must know to solve this question. Number 1, you must understand and define the term luminosity. Then number 2, you must be able to recall and use the inverse square law for radiant flux density F in terms of the luminosity L of the source. The formula to use is F equals to L divided by 4 pi d squared. Then your number 3 is to use Stefan-Boltzmann law, which is given by this equation. Use Stefan-Boltzmann law, luminosity L and the temperature T to calculate the radius of a star. The formula to use is L equals to 4 pi, constant proportionality R squared, then T to the power 4. The number 4, understand the meaning of peak wavelength represented as lambda max. Then number 5, explain how Weir's law can be used to determine the temperature of a distant star. Weir displacement law says that, the peak wavelength is inversely proportional to the temperature in Kelvin. This is a formula. So from there, you can put lambda max times temperature equals a constant. From there, you can calculate your temperature.